again to the Theories of Everything program. My name's David Tower. Viewers, this is the third program in our three-part series on time. We found in the first two programs that time was a very difficult concept, a very difficult thing to come to grips with generally, and I think that goes right back to the earliest philosophers, to the earliest scientists and physicists. We also discovered in those first two programs that the two master, if you like, protagonists of physics, Newton and Einstein, had different approaches to conceptualizing time and to handling it in their equations and in the way they modelled the universe and space-time. Newton saw it as a backdrop, a stage on which everything is played out. He incorporated it into his equations, into his differential equations, the calculus, which was a major breakthrough because, above all else, it showed that it was possible to model change and to model it very precisely in terms of time. But time itself was still, as seen by Newton, something that existed and flowed from the past to the future. But Einstein solved that, if you like. Einstein said quite specifically that time was a major part of the fabric of space-time. He incorporated space and time together based on the invariant speed of light, 300,000 kilometres per second. And that's how he arrived, by incorporating space and time together on an equal basis, in other words, because space being three dimensions, you can rotate space from one dimension to another, and time being the fourth dimension, that can be rotated into space, and as we saw in our previous programs, it can even easily exchange itself with space. So time can become space in certain situations, and space-time. They are totally on an equal footing. We also saw in those previous programs, viewers, how Einstein changed the notion of time in another very radical way. Not only did he combine it with space to form a new four-dimensional structure, one that was dynamic and which varied according to the mass and energy impact in it, and one which was totally independent of its background, of any sort of background. But he also changed the whole notion of an absolute basis for time into a relative notion for time, relative to the observer. As an observer's frame speeded up, time would slow, the frame would contract, and mass would increase for the object, for the observer, whatever, at the same time. So this was truly radical, because up until the 20th century, up until his theories of relativity, time had always been seen as an absolute thing as space was as well in Newton's time. So we now have a theory which allows not only time to be part of the universe, but to escape from its previous straitjacket. However, that straitjacket was reimposed by the new theories of quantum mechanics that were evolving. It was described in terms of packets of energy rather than continuous energy changes. It was described in terms of particle-wave duality. So matter could be described not only in particle atomic terms but as a wave. And that wave was developed by Schrödinger, who developed the wave equation. And the wave equation was able to calculate the position and momentum of a particle in space, but always over time. But always time was seen as a variable, not as an observable. In other words, you could observe and determine the position and momentum or energy of a particle, but you couldn't determine its time in the same way. So time again was relegated as a background variable into the background matrix. Now, recent experiments have challenged this actually, because a third aspect of quantum mechanics is entanglement. Entanglement is a process where two particles which once were joined may fly apart to the opposite sides of the universe, but a change to one will be reflected also in a complementary change in the other. They'll still be entangled over space. So they're one form, and this can be explained in terms of the wave function. They're in one wave, but this was seen only as acting in space. Now the latest experiments show that it actually happens with time as well. So the future and the past are also co-joined, also entangled. Changes in the measurement or position of a particular particle can affect its previous measurement of that particle. So this brings space and time together very much in the classical Einstein mode as well, much closer than previously thought, and may result in a radical reworking of quantum theory. Again, it couldn't explain gravity. There was no particle of gravity or a packet of energy that explained gravity. So still the conundrum remained, and therefore that explains the evolution of the next group of theories in the form of string theory, which was able to explain all particles and many others as well as those in the Standard Model in terms of vibrating strings, vibrating fluxes of energy, but again against a background of space and time, background dependent. But it did bring together for the first time gravity with the other three forces. So you have a grand unified theory of the four forces. However, again, relegating time. Now, the latest theory that has evolved out of Einstein's theory, which is background independent, that brings time into the equation, is the one we've mentioned a number of times, loop quantum gravity, which explains the evolution of space-time, the nature of space-time in terms of by quantizing Einstein's equations. And the quantities are in terms of networks of small particles, small quanta of volume through which information can flow, mediated by spin. They're called spin networks by the electron spin, by particle spin. Viewers, we can draw on both these theories and as well as their antecedents, which are still current of course and still have their place in our understanding. Quantum theory and Einstein's theory of relativity and Newton's theory. All these theories provide the composite from which we can construct more powerful theories in the form of string theory, loop quantum gravity, all of which give us better insights into not only the nature of matter and the forces holding them together, but the origins of the universe, the nature of space-time, the potential evolution and end of the universe. Combining them all together, combining the strengths of each of these theories, enables us to go very deep into understanding the nature of reality. And in a sense, that's what we're doing in this analysis, except we're focusing on time itself. But as we can see, time is not separate from any of these things. And one of the most important facets of time, and the one that's most, if you like, most common to us, is the flow of time. Wherever time appears, and again it appears in every change, in every evolutionary process of the universe, it leaves a trace. And if we tease out those traces, we find a flow, we find a certain pattern emerging. And the flow of time can materialise in a number of ways. We can track it down in a number of ways. One of the ways, for example, is the increase in complexity over time of both inorganic and organic structures. Now, there's a huge debate going on about the nature of complexity and how it plays out in the universe, but there's no doubt, since the universe began as a very hot and almost infinitely hot, infinitely dense spot or seed in the new universe, and expanded to become our universe, complexity has increased. First of all, hydrogen formed, helium formed, clouds of gas formed, proto-suns formed, proto-planets formed, galaxies formed, life formed on the planets, etc., etc. These have all been documented and researched, this process of growing complexity, if you like, the materialisation to us, to life today, to the first cells and then to us over the time period of the universe, 13.7 billion years. Broadly, it can be measured by the complexity of the relationships in the entity, not only of the components but the relationships and the nature of those relationships. Now if we come back to, and we see that of course in our own bodies, in the enormous complexity of our brain and our cells and all the interrelationships that make up our organs and us. Basically we can come back and see that as a function of time and related intrinsically to the flow of time if we come to the loop quantum gravity theory, which says that networks of causes and effects evolve over time and create space-time, create our universe from a very small seed. That theory also allows us to extend time backwards to create negative time, because it says this universe never really started from ground zero at all. It started from the contraction of a previous universe. And the smallest form of space-time never became a singularity, a totally infinitely dense, hot spot, if you like. It actually started from a small seed, and from that grew into our current universe, and it grew in this, which can be modelled in the form of these spin networks, or networks relating to the spin of particles creating a volume of space, which is quite difficult to understand, except that if you take it to a social level it's not so hard. Because if you have a small number of people and they grow in diversity, as Homo sapiens did in the early times of the universe, they grow, multiply, create new connections between themselves, develop civilizations, etc. You see, that is the same metaphor that can be applied to the growth of space and space-time under loop quantum gravity. So time becomes a function of the growing volume of these causal networks. Causal and effect networks, which is the basis of everything around us. Cause and effect. Even when we go back in time with so-called time machines, which we've discussed, that cause and effect, those cause and effect relationships have to be maintained. They do come under scrutiny in the process of entanglement, which we'll mention very quickly shortly, and perhaps devote a complete show to that as well. But basically cause effect is everything, and that grows over time, and therefore time is a function of this growth. And through those networks information flows from the past to the future. There we have, viewers, a flow of time, a similar flow of time at the physical level that we have in our own minds. So that's one arrow of time, one trace of time that fits and is real and is provable. Of course we've discussed the major arrow of time is talked about as entropy, the growth in disorder, the gradual depletion of energy to heat in the universe, starting off from this almost infinitely hot, dense spot and fireball and growing outwards, but losing over time, gradually losing energy, but on the way in pockets creating structures, creating galaxies, planets, suns, us. In a closed system, entropy always increases. In an open system, you can have pockets of decrease in entropy as you inject energy from the sun, say, but the sun loses overall entropy, increases its entropy, loses energy as it's supplying energy to us for the growth of us and plants and animals and everything else. So this interplay is very important, but over time, or over the epochs, entropy increases, and entropy can be measured and related directly to information again. Entropy can be measured in the number of states of disorder, the number of states of randomness. It can also be measured in the number of states, information states. The logarithm of those number of states to the base 2 provides us with an information measure of entropy, which actually is the real one, if you like. The thermodynamic one developed by Boltzmann relates to energy and temperature, can be viewed as a subset of information, of the information states of the universe. So again we come back to information. In loop quantum gravity, the flow through the networks of causal relations, and it becomes, as I've mentioned in previous shows sometimes, this is information is increasing. Information about the physical states of the atoms and molecules and subatomic particles I'm referring to here. Information about their intrinsic angular momentum, their spins, their mass, their charges. All these things are talked about by physicists as information about the physical particles. But without that information you have nothing. So information becomes the bedrock under the physical fluxes of energy that create matter, if you like, in terms of quantum theory. So this is absolutely vital to an understanding of time again, because there's another arrow. Plucked out statistically of all these changes going on is an increase in this randomness, but on the opposite side you can inject information and energy to reduce that entropy and create us. So there's the second arrow, there's the second trace. Now the quantum theory, which I very briefly discussed before, which has been the major experiment of quantum theory, the interference relationship that shows a photon or a particle moving simultaneously through two openings and creating a wave-like interference pattern. And if a measuring device is used, whether it's our brain or some other indirect measuring device that measures, that knows which slit this light is going through, which these photons of light is going through, once we measure this phenomenon, it collapses, it decoheres, and this is very important to the development of quantum computing and everything else. It's a phenomenon that happens, and it happens one way. As soon as we measure and assess the amount of information in that system, it collapses from multiple states, from a probability state, if you like, to one classical state, to the particle itself, or even to the universe or us. There's a vast, of course, amount of literature on the philosophy of this process of decoherence, as it's called, but it is a one-way, has a direction in it, from multiple states to quantum states to a single state that we can understand in our brain and our mind, and which seems to be vital to our understanding of the universe. So viewers, this leads us to the core of this third program, relating to the flow of time and its relevance to us as humans, because in all the science, in all the programs that we do, whatever the science is, whether it's the science of the cosmos or biotechnology or the mind or whatever, we're looking at its relevance to humans. And of course time is, as mentioned in the first program, just absolutely critical. It controls the body clock. We get a sense of time through our body clocks, through the seasons. We build our life around this thing called time. And when we boil that down again, we get causes and effects and changes. We know that one change is caused by something else results from a particular change. That is how our knowledge grows, our understanding of change and of evolution, which takes change to another level. In fact, we'll be running a series on evolution in the near future, but evolution does more than just change something. It sifts information out from it. It sifts useful, relevant information and continues on. That is the core of an evolutionary process, and it is directly related to how we use time in our day-to-day life. And of course time is mediated for all life, and us in particular, because of the level of brain development that we have evolved over since we began, since life began on this universe. We understand life through time, through the flow of time. You've seen some previous shows on the nature of reality, some previous shows on the nature of identity and the nature of ourselves. And in those programs, the key feature is that we retain an identity through the use of memory, through the capacity to also think in terms of scenarios in the future, but basically everything that happens to us in a causal way, and that's everything. snapshots are taken at different times depending on the individual and creates a memory of a life, of an identity. And we intrinsically know that time flows from the past to the future because that's the way it's embedded in our mind, embedded in our memories, embedded in our identity. Without that, our life would be a jumble, and people who have got major problems, Alzheimer's, dementia, etc., lose track of this flow. Their memory fails, therefore they start to lose track. If you like, their memories decohere in a sense, and they can't keep this flow going. They can't remember their past and why they did particular things, what caused them to be the way they are at the moment, and particularly they don't get that feedback that's so vital to keeping on track and surviving, if you like. In other words, it's only through the past memories, understanding their relationship with other memories and the present and the future, that we can best survive and learn from the past. That's what it's all about. And that's how we evolve, as we process information from birth to death. Because that's another key way of looking at the process and the progress, if you like, of human life. We take information and knowledge in, we have structures to absorb it in our mind, we process it, and again, even matter can be looked at as a form of computing, because all the spins and interactions but in matter itself are a form of processing of input-output. We definitely produce output. Our outputs are our children, our careers, our interactions with others based on our knowledge, all related to the flow of information and the flow of time. So what we've evolved, viewers, is a form of subjective time to complement proper time, the time that can, or objective time, the time that can be measured by clocks, even if it is in a relative form, according to Einstein's equations. Subjective time is something else again. Subjective time allows us to synchronise our actions with the events going on in the world around us. Whether that's other members of our group, whether it's the seasons, whether it's day and night, whatever it is, we need to synchronise to survive. We need to coordinate our actions to survive in this world. So that subjective time has evolved. It's allowed us to go back in time, forward in time, to compress time, to extend time, to manipulate time in accordance with, again, our requirements. For example, the rate of change today is much talked about. Change is speeding up, so-called, and no doubt it is. So the number of events that are occurring in a given time frame are increasing. And we're aware of this in our subjective time, but we modify our brain time, if you like, so that we can absorb those events, so that we can cope with them. So time may in one sense be speeding up, but in another sense we're compressing more and more processing into a smaller and smaller time frame. So in fact we're slowing time down internally in our subjective time in that sense. And eventually, for example, it may be possible, well it is possible perhaps theoretically, if we're in a black hole, for example, time slows down to such an extent that an outside observer can see an infinite number of events occurring from the outside within their subjective time, if you like. So we could put a problem that's uncomputable in this in the normal environment with someone in a black hole and have it compute an infinite number of events and solve that problem for the outside observer. So again, we've looked at time in this series to try to understand how it relates with other aspects of the universe and how it interacts with us, and to see if we can tease it out, to see if we can untangle it. But in that regard we've failed, because it's not able to be untangled. It's an integral part of space and energy and information and of our own evolution and the evolution of the universe. So what we've discovered in this series is that time is an artefact that we've created. It's an artefact that we've created to understand the universe and our place in it. And it always will be just that, a part, an integral part and an essential part of our universe and our future evolution. I'm David Tao, and you've been watching the Theories of Everything program again. I'll look forward to seeing you again next week.